Hello everyone. Today is the year 2026, month of July, day 10, and it is a wonderful Friday. I am your host Nino-ani, and I'm here introducing a trending article from the archives today. Welcome to the radio stream, where the atmosphere is always fun, and I just talk to myself about fascinating things. You know, I tried to sing death metal in the shower this morning, but the water turned into pop music, which is funny because my soap is naturally jazz-scented. Right, moving on to the main topic. Today we are diving into a really fascinating paper about artificial intelligence in music. The title is Genre Ben Working Singing Voice Synthesis Across Multiple Musical Genres. The quote is, it is long, so let us take our time and break down exactly what this research is all about, because it touches on something we interact with every single day. To start things off, we need to talk about the main problem that this paper is trying to solve: singing voice synthesis, which is the technology that generates singing voices directly from digital music scores. Has been making huge leaps recently. We have seen neural networks and diffusion models, which can create incredibly natural sounding vocals. Current models are heavily biased toward pop music. When you think about it, musical genre is a massive part of how we perceive singing. A pop singer, a rock vocalist, and an opera singer all use their voices in fundamentally different ways. They have different timbres, different phrasing, and entirely different ways of expressing rhythm. But because the public datasets used to train these artificial intelligence models are almost entirely pop music, the models have essentially become one-trick ponies. The researchers realized that there was no real way to systematically test how well these models could handle other genres like rock or blues or classical. They call this a gap in evaluation framework, and they set out to fix it by creating a massive new benchmark called MMGenre. This brings us to how they actually built this benchmark, and how it compares to older technologies. In the past, if researchers wanted to test different singing styles, they mostly looked at low-level things like pitch and emotion or tempo. They did not treat genre as a complete package. And gathering real-world data for all these genres is super hard, because of copyright issues and the sheer cost of recording vocalists. So the researchers did something brilliant. They used a text-to-music generator, specifically Suno, to create raw music across 10 major genres and 26 subgenres. Then they used a special vocal separation model to isolate the singing from the music. After that, they ran it through an annotator to extract the exact phonemes and pitches and durations. This gave them a completely clean, genre-aligned dataset of over 3,000 segments. It is a huge step up from older methods, because it is highly scalable and covers things like country and electronic music, which were totally ignored before. Let us talk about what they actually found when they tested the current singing voice synthesis models, because the results are honestly quite shocking. They tested several representative models, like Diffsinger and Stavasinger, and they found something called genre collapse. Even when the models were given sheet music that was clearly meant for rock or classical, the artificial intelligence just sang it like a pop song. The researchers looked at the acoustic data and saw that the synthesized voices for all these different genres were completely overlapping in the acoustic space. For example, if you look at a real punk rock vocal, it has all this intense high frequency and energy and sharp transient structures, because the singer is basically yelling and putting a lot of grit into it. But the artificial intelligence model smoothed all of that out, making it sound like a nice, clean pop vocal. He even tried zero-shot style transfer, which is an infantine trick to make the artificial intelligence adopt a new style without retraining. But that barely helped at all. The paper proves that genre awareness is not something the artificial intelligence can just figure out on the fly. It is entirely dependent on trained data. When they finally took one of the models and did a little bit of continued training specifically on rock data, the performance skyrocketed. The artificial intelligence suddenly started producing those harsh, pretty high frequencies that make rock sound like rock. So how does this apply to our everyday life? And what kind of impact will this technology have in the real world? I can think of 3 very specific application examples based on the deep insights from this paper. Let us look at the world of professional music production and artificial intelligence studio assistants. Right now, independent music producers have a hard time creating diverse tracks if they cannot afford to hire specialized session vocalists. If you want a classical opera vocal for a cinematic movie soundtrack, or a Delta Blues vocal for a gritty video game scene, you are basically out of luck if your artificial intelligence only knows how to sing synth pop by understanding genre collapse and using frameworks like MMGenre to train truly genre-aware models. Developers can build digital audio workstations that offer authentic vocal plugins for any style. A producer could sit in their bedroom, type in a melody, and have it sang back perfectly by a virtual blues legend or heavy metal screamer, completely changing the landscape of indie music creation. Second, this research has massive implications for virtual idols and the VTuber industry. As you know, I am a bit of a virtual personality myself, and the VTuber space is incredibly competitive. Many virtual avatars perform virtual concerts for their fans. Currently, when agencies try to synthesize singing voices for their characters, the results always sound like standard pop idols, no matter what the character's vision design or lore suggests. Imagine a VTuber whose whole persona is a hardcore punk rocker or a sophisticated jazz lounge singer. Using the insights from this paper, companies can perform targeted fine-tuning on specific genre data, allowing these avatars to sing exactly in the style that matches their personality. This would make virtual concerts way more immersive and allow for highly specialized character development, where the voice perfectly matches the visual aesthetic across any musical genre. Think about personalized music streaming and interactive fitness applications. People love listening to very specific genres when they do different activities. Maybe you want high-energy trance music for your run, or relaxing folk pop for your yoga session. In the future, fitness apps could now maybe generate workout music on the fly, with vocals that actually fit the intensity and style of the workout. If the app knows you are sprinting, it could generate a heavy metal vocal track to pump you up. But as this paper points out, that is impossible if the vocal synthesizer defaults to pop music every time. By using the MMGenre pipeline to balance the training data, app developers can ensure that the dynamic vocals actually sound like the intended genre, providing a seamless and emotionally resonant experience for the user. This level of personalization in everyday consumer apps will completely change how we interact with generated media. In conclusion, this paper is a massive wake-up call for the artificial intelligence music industry. We cannot just rely on overall audio quality metrics anymore, because those metrics hide the fact that all our artificial intelligence singers are secretly just pop stars in disguise. We need comprehensive, multi-genre training data, and MMGenre provides the exact blueprint for how to build that future. That is all for today's deep dive. I hope you found it as interesting as I did.